to video 8.8b, part 1, more improper integrals. And this is where the integrand is undefined at a limit of integration. Check where's the integrand undefined, and then check and see, let's say it's undefined at 2. Check and see if either one of the limits of integration is 2 or if 2 is between the two limits of integration. So this is numbers 37 through 54. Determine whether the improper integral diverges or converges. Evaluate the integral if it converges, and then check your results with the results obtained by using the integration capabilities of your graphing utility. Let me just get this view better. Full screen. Okay. All right, so actually I think these directions are in the reverse order because you won't be able to determine if it diverges or converges until you try and evaluate it. So if you evaluate it and get a constant, then it converges to that constant. If you get infinity, negative infinity does not exist, then you'll simply say it diverges. Okay, so this is like number 38. It's not quite number 38. So the question is the integral from 0 to 4 of 8 over x dx. So the first thing you have to notice is that 8 over x is undefined at x equals 0, and 0 is one of the limits of integration. So you have got to rewrite this as a limit, and we've talked about that before. You have to write an improper integral as a limit. So what we have is the limit as x approaches 0 from the right. Now that's going to be important from the right, and that's because we're between 0 and 4. Well, if you're between 0 and 4, you're to the right of 0. So you're going to be, whoa, I think it's there. Sorry about that. Okay, so you're going to rewrite that 0 as a, and you're going to have the limit as a approaches 0 from the right. So the limit's the last thing we're going to do. The first thing we're going to do is actually evaluate the integral. So we have 8 times 1 over x. The integral of that is 8 times ln absolute value of x, and we're evaluating that from a to 4. So we will plug in the upper limit first, which is 4, and then we'll plug in the a, which is the lower limit, and we'll subtract. So we get 8 ln 4 minus 8 ln a. Now 8 ln 4 is just a constant, but what's happening now is we have the limit as a goes to 0 of 8 ln a. So if you think of the graph of y equals ln x, the limit as x approaches 0 from the right is negative infinity. So we have 8 ln 4 minus 8 times negative infinity, which is 8 ln 4 plus infinity, which of course is infinity, and therefore this particular improper integral diverges. Okay, this is like number 46. Again, the first thing you have to pay attention to this, and you're not used to, you really have to look, where is this function undefined? Where's the integrand undefined? So, of course, being a radical and also being in the denominator, and it's an even root, your radicand has to be greater than 0, and of course it can't be 0. Normally we would say greater than or equal to, but we can't because it's in a denominator. That's a quadratic inequality, so you're going to factor it. The two numbers that would make it equal to 0 are 2 and negative 2. And then because both of these factors have odd exponents, the signs will alternate. Plug in 0. You'll get 2 times 2 is positive, so it's negative, positive, negative. We want to know when it's positive, which is between negative 2 and 2. So the problem is, even though it doesn't exist at 2, and we have 0 to 2. So we have to replace the 2 by a variable. Let's call it b. Limit is 2, b approaches 2 from the left. Now again, because the integral is 0 to 2, we are on the left side of 2. So that's why it's the limit as x approaches 2 from the left. Now hopefully you'll recognize this as an inverse an inverse sine. So our 4 is 2 squared, so our a is 2. Our x squared is our u squared, therefore our u is x and our du is dx. And therefore we will now be taking that integral and getting an inverse sine. So we get the inverse sine of our u over a, which is x over 2. We're evaluating that from 0 to b. And we plug in the b, we plug in the 0, inverse sine of 0 is 0, And now we're going to do the limit. So its limit as x approaches 2. In this case, it doesn't matter from the left or right, because 2 over 2 will give us 1. And the inverse sine of 1, of course, is pi over 2. Because remember, the range for inverse sine is negative pi over 2 to pi over 2. So we get pi over 2 minus 0, which is pi over 2. So it obviously converges to pi over 2. Now the Gabriel's horn thing, I'm going to show you that. Gabriel's horn, if you were to take f of x, we had 8 over x, but if you just took f of x equals 1 over x, and you took, you looked at it from x is greater than or equal to 1. In other words, this would go on forever and ever and ever to the right. But a really interesting fact about this is that it will have a finite volume. So when you set up the integral, it'll be an improper integral to find the volume. It actually will converge to a number. And then in the next section, we're going to be looking at section 7.4. We're going to learn about surface area. And that also is an integral, an improper integral, because of the 1, because we're going, it's just an improper integral because it's 1 to infinity. I don't know how to make that stop. When you evaluate that improper integral, it's actually going to diverge. So kind of interesting that this infinite horn has a finite volume and yet an infinite surface area.